And it looks like we're live. Here we go. Let's make sure everything's up and running. Looks like it's pretty good. Is it running? It should be. I don't know. It's not coming up yet. Oh, there it is. Now it's running. Okay. Okay, so we're live on YouTube, Twitter, everything else. And there we go. On to page 2. Okay, good. Okay, we have a lot to talk about. We'll see just how many people are joining us tonight, as we are also dealing with Mets versus Yankees. I get it. It's a big game for Met fans and Yankee fans. I got that over here. We also have some interesting climate discussion that I wanted to touch on tonight with the AMOC and the Gulf Stream. There's a lot of confusion out there, a lot of misrepresentation, and also some very interesting data coming out there for whether or not the AMOC is going to collapse. It's a complicated question, and one which I think needs a lot of detailed analysis. So we're going to hit on that tonight, and then we're going to talk about what's going on in the tropics and also what to expect over the next couple of days with this searing heat that's invading us, followed by the threat for thunderstorms, or at the same time thunderstorms, and a few of those could be severe as well. So we'll be keeping an eye on that. But first, let's check out the AMOC. So this is the AMOC. It's the Atlantic Meridional Total Overturning Circulation. I do have an amazing knack of butchering the English language. But basically, if you go to oceanservices.noaa.gov, you can find this information. It's free. You can find it anywhere. And essentially, what you have here is a very old circulation, a very slow circulation. It takes 1,000 years for a water parcel to make the full circulation around the Earth. So this isn't like a fast-moving water jet stream. It's slow-moving, and what the goal of the AMOC is to transport salt, highly dense salt-filled water, cold water, from the Arctic down into the tropics, and then the warm water surges from the tropics northward. Now, the AMOC is not the Gulf Stream. This is the Gulf Stream. So, what's with all the confusion? What's going on with the idea of basically the whole thing collapsing? Well, I've written a chart for you. And it took me a while, but let me just get this here. Okay. I hope everyone can see this okay. This is the AMOC. Okay, and I'm going to step over here. Now, the Gulf Stream, which is right here, that's at from about 0 to 1,000 kilometers down into the ocean. It's surface. So it impacts like hurricanes or winter storms. It transports moisture. It transports warm water northward from the Gulf of Mexico into the northern Atlantic and towards Europe. This process helps to keep Europe warm. Notice Great Britain, back here, is much further north than Boston and New York City, but it's much warmer in the winter because of the Gulf Stream. There is no indication, zero indication that the Gulf Stream is going to collapse. Why? Because the Gulf Stream isn't driven by salinity. The Gulf Stream is driven by centripetal force, i.e. the rotation of the Earth. In fact, let me show you something really cool. There is a clone to the jet stream, to the Gulf Stream, in the Pacific. Want to check it out? Well, let's take a look. We're going all the way to Japan. Same situation with the land masses, same circulation with the water. Because of the circulation of the earth, you get this transport of warm water up through the east coast of Japan out into the northern Pacific. But it's not as far north as the Gulf Stream. It's close, but not as far north. And the reason why it's not as far north is because of the AMOC influence. The AMOC is this sucker right here, the blue and the red. Now, the blue area, on average, is 3,000 to 6,000 meters below the sea surface, on average. That changes as you go further north and south and the density of the water. But that's basically the average. And the reason why it's lower is because as the warm water lifts northward, it interacts with colder air and that water starts to freeze. And there's a separation in the salt water between the water and the salt. So the salt sinks further south, sinks further into the depths of the ocean, and you get a colder, denser water, which naturally gets transported down towards the tropics. Meanwhile, as that water is warmed, as it's going down towards the tropics, it starts to lose that salinity and it starts to rebound back northward. The AMOC kind of buffers and supports the Gulf Stream and allows it to get a little bit further north and west. If the AMOC collapses, hypothetically, the Gulf Stream is still there, but the Gulf Stream is going to end up further south. So, not much change for the United States, but pretty significant change for Europe. Now, why is there this idea that the AMOC would collapse? Well, let me go back here. Okay, so the idea is that with the sea ice melting and with the glaciers potentially melting around Greenland, that introduces more fresh water, less salt. So you're disrupting the whole salinity process, possibly. So the idea is that if we keep on seeing the ice melt, then you increase the amount of fresh water, which then disrupts this whole circulation. The problem with this is that thus far there is very little data to support the actual observations. And one of the ways that I keep an eye on that, and again, this would take, it's not going to be a fast process because you still have a natural process controlling this whole circulation. You have the salinity, you have the circulation of the earth, the centrifugal force, and then you have the natural thermal gradients. The only process we're actually watching for is that change in salinity. All the other features, like the earth isn't going to stop circulating. That's still moving. Okay, the earth isn't going to stop moving. So all those factors are still present, right? So the idea is that if we add enough fresh water into the circulation, in theory, it would slow down and potentially break up the AMOC. Maybe. But then there's a wild card in that. Because once it's broken, then you no longer have the transport of the warm water into the Arctic, which means everything starts refreezing again. So this would lead to pretty significant cooling around Europe, possibly another ice age in Europe, okay? And it would also lead to a recooling, a refreezing of the Arctic. So then you kickstart the whole process all over again over the next 1,000 to 2,000 years. Notice I said 1,000, 2,000 years, not 50 years, not 20 years, not 10 years, not every 10 years, depending on the politician, thousands. So this is a very long process. So the study that was put out has some interesting theories. And theoretically, yes, if you add enough fresh water, you would disrupt this whole circulation that we have in place here. Okay? But as you can see here, one of the best ways to tell whether or not that's happening is to see whether the Gulf Stream here is no longer being able to reach the northern Atlantic. And as you can see here, there's no sign of that happening. There is literally no sign of any type of indication of a of any change in the current speed. Like, the Gulf Stream is not slowing down itself. There's no indication of that. You can see the sea surface temperatures here. You can see it clearly transporting that warmer water northward. There is no data, no observational data. And there has been no observational data of significant salinity. Could that change over time? Absolutely. You know, we'll be keeping an eye on that to see if that changes at all. But right now, I'm not seeing anything that is significantly changing in this process. So we'll continue to keep an eye on it. But this is not a 50-year process or a 25-year process. Anyone who's posting anything or putting any news stories out saying that this is going to collapse should be severely questioned. Severely. Because there is no data to support it. But more importantly, if you go check out the IPCC report, if anything, it would possibly happen after 2100. So maybe 2150, somewhere like that. That's pretty much the majority of the models. The model guidance that was used in this study, everyone agrees it's very rudimentary. It's very basic. It only included the salinity of the ocean. It barely included anything like centrifugal force or the natural evolution of the sea surface temperatures. And by the way, I know there's a lot of talk about how warm the Atlantic is, and it is above normal. I do want to point out the reason why you have well above normal waters over the northern Atlantic is because you also have, and we'll switch over to air, and we'll switch over to 500 millibars, and we'll switch over to, let's see, pressure. And what you have is a very powerful ridge in place over the northern Atlantic that we've had most of the summer. So you have a ridge that feeds back on itself, allowing for rapid warming of the water. There's your above normal sea surface temperatures in the northern Atlantic. The central and southern Atlantic, that's more driven by, you guessed it, the AMO, which is part of the AMOC circulation, and this time we're in a positive state. So again, everything can be, this isn't something like, oh my God, I don't know what's happening, maybe something weird, volcanoes, carbon dioxide. No. This could all be explained very, very easily with basic knowledge that we know already. Now, I'm sure I'll get more questions on this, so I'll be asking about that. So I'll answer those questions, obviously, as we go on through. We already have some great questions on the live chat. We'll see what we get on YouTube. But I wanted to explain that whole situation with AMOC just because there's a lot of confusion out there. There's that ridge I was talking about. There's a lot of confusion out there, and I don't want there to be any fear running around out there. You know how things are. So, no, the climate isn't collapsing. Okay? The tropics, though, well, tropic activity sure is collapsing. There is basically nothing going on right now in the tropical Atlantic. It is very quiet out there. And you know why? Because of El Nino. El Nino is rocking and rolling. We have plenty of dust and dry air out in the Atlantic. And if we go back here to our winds, and let's pull up 850 millibar winds to start. And you can see The winds are going from west to east. I mean, east to west, right? Pretty standard for the tropical Atlantic. But when you get up to 500 millibars, this is what we talk about with vertical wind shear. When we get up to 500 millibars and 250 millibars, you could see the development of troughs and winds going counter to that east to west circulation. What we have here is a lot of vertical wind shear. So, shear plus dry air, and a lot of dry air at that, means not much is popping around. And unfortunately, a lot of people get caught up in the model guidance here, starting to post model guidance from the GFS, 300 hours out, all sort of nonsense. The most we have so far on the European is maybe a week low, barely a tropical depression in strength, in the central Atlantic to the north of the Lesser Antilles in about 5 to 7 days, maybe. Here's my general rule when it comes to the tropics, guys. Don't trust model guidance until you get a warm core low. Because warm core lows are mesoscale driven, small scale driven, and what that means is that things as small as dry air at any level, 925 millibars, 850 millibars, a minor shift in wind shear, all these little things that synoptic models have a hard time picking up can severely disrupt a tropical low pressure system. So I would severely suggest not trusting any model guidance beyond 90 hours in terms of hurricane forecasting. There's just nothing out there that really stands out to me and says, hey, look, we have a support for a active season picking up. It's not there. And you might be wondering why. And part of that is our El Nino. And the reason why I'm very confident in saying that is because our SOI is free falling like a rock. The daily contributions here are becoming increasingly more negative, and it matches up very nicely to what's happening with our convection. Let's see here, right here. See our convection just keeps on firing around the date line. So that's starting to match up nicely. The convection, in fact, influencing the subtropical jet stream is starting to take shape. And we're also seeing a little bit more activity here in the tropical Pacific. Again, mysteriously very quiet here in the eastern Pacific. Normally during El Ninos, we see a lot more activity picking up, but not much really taking shape. Could be watching something here for Hawaii, but that is about it. And then, of course, we have a very powerful typhoon heading through the Philippines. This is expected to head into China, which matches up to why we're seeing a relaxation in our pattern right now. That's going to allow for a very hot weather pattern to take place. But this falling SOI value here tells me a couple of things about our pattern. One, the heat ridge doesn't have much life. It's going to crash pretty quickly. Okay, so by Sunday, it's done. So we essentially have oppressive heat for today, tomorrow, should I say, Friday and Saturday. And then we start to shift more towards a polar air mass invading once again by Sunday. We also, with this support, basically see a stronger subtropical jet stream and an increased potential for vertical wind shear and dry air dominating much of the tropical Atlantic. In short, I don't see much changing all the way through August, so maybe we'll see an uptick late August and September. We'll see, but the idea of a well above normal hurricane season for the tropical Atlantic is in trouble for those that forecasted that. So again, we'll continue to see how the trends continue to move. Closer to home, well, humidity is starting to increase. Temperatures right now are in the upper 70s to lower 80s throughout the region. The key thing I'm keeping an eye on are those dew points. Notice in central Jersey, we have them in the lower 60s, but then as you head down towards southern New Jersey, they're in the upper 60s to lower 70s, even mid 70s here around Wildwood. And a lot of that is driven by what is changing and what's evolving in our weather pattern. High pressure is pushing off the coast. Warmer air is surging northward. And it's all driven by what we're seeing here with the polar jet stream lifting northward. So the polar jet stream relaxes, right? So we still have this weakness between this ridge and this ridge, but the heights overall are rising. So as a result of the heights rising, you get a lot of tropical moisture getting drawn northward from the Western Atlantic ridge. And the heat that has been building here in the plains at 850 millibars surges towards the east coast. So you have a combination of 850 millibar temperatures pushing towards 20 degrees Celsius and increasing low-level moisture. Combination of the two basically supports temperatures in the mid-90s to lower 100s and a heat index over 100 degrees. The good news is that we already see an end to this pattern with this trough deepening right here. So as this trough deepens around the Aleutians, it allows for this whole ridge complex to build again and a trough to return back towards the eastern United States with polar air returning. So you basically see the end of this hot and humid weather pattern before it even begins. And you can see the edge of our tropical air mass here and the heat. Let me see if I can zoom out. In fact, let's go full sector United States. And you can see this really taking shape here. Here's the Western Atlantic Ridge influence. Here is the hot air mass that's lifting northward. And you can see right now we're in between the two. We take a look at moisture transport. You can really see that starting to evolve here very nicely. So as the heights rise, the Western Atlantic Ridge expands. And then when we go to 500 millibars, you can really see the interaction between the two. So there's our polar jet stream lifting northward, and the ridges kind of have a brief marriage together with the same 500 millibar height decameters interacting. So this allows the heat to surge towards us, as we can see here. So we have the heat, we have the humidity. What about the potential for thunderstorms? Well, let's take a look at a water vapor satellite picture. While all this is happening, these short waves in the polar jet stream, which the jet stream still is very energetic, is going to continue to send these short waves marching through the Great Lakes and towards northern New York. These short waves will not move, the brunt of the short waves will not move through our area, but with plenty of moisture, plenty of heat supporting plenty of instability, you don't need much of a trigger to really support lines of showers and thunderstorms. And so we're watching this short wave here for tomorrow and this short wave up here for Saturday. And then this short wave way up here for Saturday night into Sunday. So what's going to happen is that this one marches through, but again, the whole polar jet stream up through about Saturday afternoon will be lifting northward. So this short wave marches through Lake Erie and then up towards the St. Lawrence River Valley. So the southern edge right here is what swings through our neck of the woods, and that's what opens up the threat for thunderstorms. This short wave up here swings through the northern plains, swings through the northern Great Lakes, and then swings to the north of New England on Saturday afternoon, and that allows for scattered showers and thunderstorms on Saturday afternoon and evening. Not much in the way of tornadic development, but certainly straight line winds would be a threat with both of these features. The final short wave Saturday night through Sunday, well, that will be moving through as the polar jet stream starts to dig again. So it's going to have more influence from polar air masses, and that's going to drop through the central Great Lakes on Saturday, and Saturday night through Sunday through the mid-Atlantic, and that's going to drive polar air. So you can see all that based on what we're seeing here on the water vapor satellite picture. And what does that look like on the model guidance? Well, essentially it looks like this. There's our first short wave. Let me see if I can zoom in here. So that way you guys can see it. There we go. It's better. There's the first short wave. There's the second short wave. There's the third short wave. And so how does that look at 850 millibars? Well, there's the heat for tomorrow, Friday, hot and humid. I can't rule out a few isolated showers and thunderstorms, but Friday is going to be one of those days where it's going to be like 100 and heat index 105. And it's just going to feel horrible in the Delaware River Valley. And then on Saturday, the next short wave, notice we start to see a fall in the 850 millibar temperatures on Saturday night. And then Sunday with that cold front, we get a true polar air mass built in and comfortable temperatures take hold. So that's why we're seeing in the various mesoscale guidance here. We'll start off first with the HRR. And let's see about pulling the latest data here. And we'll do 18Z. You can see for tomorrow afternoon, evening, there's our first wave of showers and thunderstorms. Again, when it was out to 48 hours, it was showing a very robust signature. I always warn, try not to trust the HRR when you're getting out to 48 hours. I know it looks cool, but it can lead to some false narratives in terms of the intensity of these storms. But with all this heat in the atmosphere, I definitely like the idea of vivid lightning and very heavy downpours with this setup coming through. And then Friday, it's not showing as much. Let's take a look at the NAM guidance here. Again, the NAM shows tomorrow afternoon a nice line of showers and thunderstorms, heavier rainfall, a few isolated severe thunderstorms. Friday, not as much because we don't have that shortwave interaction. And here we are on Saturday, more scattered showers and thunderstorms starting to develop. And then we have our cold front move through Saturday night into Sunday, which again is showing up pretty nicely on the European guidance. By Sunday afternoon, it's beautiful. Humidity's falling, and it's very nice outside, so you can get out there and have some fun. As far as our pattern overall, beyond that point, well, we're going to fall right back into our active weather pattern with plenty of polar air masses moving through. We had our hot stretch. I think this is it as far as major heat waves. After this, much of August appears to remain the same, with a trough either over us or to the west of us, keeping us very active with showers and thunderstorms. I don't really see much of a change in that pattern because I don't see much of a change in the forcing mechanisms of our pattern. So what we've seen is what we're most likely going to get. Now with that, let me go back here. Hope you enjoyed my little chart there. Let me answer some of these questions. We got some pretty good questions here on the live chat. As always, you guys do an amazing job. And we also have some questions here on YouTube as well. And we'll see what we get on Twitter. Twitter is always, or what do they call it now? X?
X Twitter is what I'm calling it.
X Twitter, X Exhibit?
I don't know.
I don't know. You know, I don't know. But I just feel that when I saw X, I just had this flashback of like a bunch of late 90s, early 2000 rappers in which everyone was using X. And I'm like, Extreme. Yeah, Extreme. There we go. I think Elon was about, I don't know, about 20 years too late with this one. But we'll see how it goes. Okay. Let's see. Atlantic City was great earlier this week. Awesome. Dr. Ryan Millell, I know him very well, had a great response to all the hysteria, pointing out the previous years where there was intense heat, including the bulk of the 1930s. Very clear the hysteria was political driven, given the open demonization of political opponents by alarmists. Okay, so my one pet peeve with a lot of the warmest ever declarations is that it only starts at 1950. Go from the 1800s. You have a much stronger argument. Because if you go by 1950s, it's very clear what you're trying to leave out. you know? And the thing is this, but we need to remember we're very localized in our thinking. The 1930s is hot for us in the United States, not the whole world, though, okay? The heat wave that was driven in North America was driven by partially the weather pattern and also partially very poor farming practices, which basically destroyed the plains and led to basically dust all over the place because of the way that they were handling the soil. So that led to a feedback process which built up a ridge, which led to a constant the heat build, so the ridge build, which built the heat, which built the ridge, so on and so forth, and that continued all the way into the fall, and you ended up with some record-breaking high temperatures as a result. That wasn't the case for the entire world. Again, you guys know how I feel about using air temperature analysis to explain global warming. I would prefer precipitable water values because then you get an idea of the density of the atmosphere, the expansion of the heights and how that interacts and why that interacts with CO2 and whatnot. So that's why I always feel that we're missing the mark when we go into those discussions and use that type of data. Good evening, Stephen. 2 questions for you this evening. This is from Rob Allen. I saw a very interesting opinion editorial that the significant warming waters off Maine, New England may impact a lack of may be impacting a lack of low pressure development over the last year during nor'easter season. Any thoughts? It's an interesting idea. I think it could have had the start of a feedback process with that, because you're reducing the transport of polar air masses, which means that your water temperatures may be slightly warmer. I think the primary feedback right now is because of the ridge that remains in place over the northern Atlantic, specifically to the south of Greenland, which we could see. Again, let me see, where did I put that data? I know I have it somewhere. Here we are. Let me pull that up. Okay, that right there, that ridge has been out there all summer. And the problem with that ridge is that the way that it's situated and the way that it has intensified in the Atlantic, under the normal heat ridge you get from 500 millibars down to the surface with our Western Atlantic ridge, it enhances the ability to heat up the water, okay? So the water is taking up this heat because we have a constant ridge that's rebuilding on top of it, which is enhancing the water temperatures. Which, combine that with everything else that's going on, that's how you get to where we are right now. But it's still something I think that needs to still be studied, and very interesting data to say the least. But it's a good theory on the start of the feedback process. A reminder that all those wind turbines use oil to lubricate bearings are necessary to keep them spinning when the wind blows. Okay, random, but sure. Sure, I guess, yeah. Second question. With the SOI continue to have rapid free fall, as we saw, does this pause your opinion on a weak to moderate El Nino for the winter? I definitely see. The thing is this: I don't see a lot of support in the subsurface here for a super strong El Nino. Plenty of support for a weak to moderate, well, especially moderate El Nino. But let me see if I can find that data. 1 minute. I will find it for you. Okay. Now I will pull it up in just a moment. After I find it. There it is. Okay, we're going to take a look at the subsurface, because this is what has my attention. Okay, and now we'll put this on. There we go. Okay. When I'm looking for a strong El Nino, a robust, powerful El Nino with sea surface temperatures driving above 1.5 degrees Celsius and remaining there sustained, I do not look at that. That right there is not what I'm looking for. This is the decline of warm temperature anomalies in the equator. So the upper ocean heat anomalies start to fall off. And when you start to see this, it doesn't mean El Nino is going to collapse. But what it means is that you're losing your support for your El Nino to continue to be driven. And you're starting to see more and more cold water patches showing up here. So what I think is going to happen is that I think we're going to stall out at 1.3 to 1.2 to 1.3. And I don't think we get to that strong status, but we definitely are moderate. I think we get above weak. We're already there, really. When you take a look at the anomalies here, right here, we watch always 3.4 for that status, and you could clearly see that being the case. So I like the idea of a moderate El Nino with convection focused around the date line this year. And then, well, we'll talk about more about everything else that's going on with the insanity of what's going on in the stratosphere with the volcano influence and how that's going to work out and what we learned from last year. And then I'll probably beat my head against a wall because I'm not sure how to work with that. That's going to be a very complicated factor. This should be interesting. FYI, AC has wind turbines right by... Oh, I see. Did the wind turbines interrupt your the gambling? I gotta ask. By the Borgata, it's by the Borgata. I went to the Borgata. Funny story. My brother had had his bachelor party out there, and I don't drink, right? So I'm going out there, and you should not play blackjack with a meteorologist. We know we do very well with math. And I did very well on the blackjack table, and they were very annoyed. So that was fun out there. Got a pretty good room, but a very interesting day out there. During the heat of the day, only one was spinning slowly. The others were still. Well, all right. Well, there's the thing with wind power. FYI, or this is from Carter. FYI, I saw the clouds that were part of the storm that caused that damage in Union. Oh, okay. If there was any directional shear that could have caused rotation, would definitely have ended up being a tornado rather than straight line wind bursts. You could see the clouds hanging real low and rising rapidly, and where some of the ominous looking clouds I have seen. Okay, so what you saw was rapid uplift and then the air cooled because the rain cooled air, and then rapid downdraft. Could that have caused a circulation if we had vertical wind shear? Hypothetically, yes. The one thing though, by where that location was and where we saw that amplified, it was near a more stable air mass, so that could have interrupted that circulation. So that's a bit questionable. But certainly a possibility, especially the way this year's getting. As far as heat waves go, we have had much hotter and longer around New Jersey. Absolutely. Typically with El Ninos, you do not see prolonged heat waves. It typically shows up with La Ninas, and we've been very lucky in that respect that we haven't seen a lot of that. And fingers crossed, I would like to keep it that way. What we have seen, though, is a lot of high-level humidity, which is horrible because you just can never get cool. It's just annoying. I do not like it. What are your thoughts on severe threat for tomorrow, and is there another severe threat for the weekend? If I'm going to be watching for severe thunderstorms, which I will be, I'm going to be looking for the Poconos, the Catskills, and northern New Jersey, because those locations are going to be closest to the shortwave that's going to be diving towards our region. That doesn't mean that you won't see a severe thunderstorm down towards the Delaware River Valley in central and southern New Jersey. But that's where I like it the best because that's where we have the strongest lifting and the strongest vertical wind shear via speed shear in this situation, especially 850 millibars. Instability will be highest in the Delaware River Valley, southeastern Pennsylvania, southwestern New Jersey. But the one thing I don't like about the severe pattern is that a lot of the focus is more towards central New York and the St. Lawrence River Valley. So what you could have set up here, and let me see if I can pull up some guidance here to kind of illustrate this. Let's see here. Okay. So just a hypothetical, okay, and this is the NAM guidance here. The one drawback to a severe weather is that if this line ends up being stronger than this line, as in terms of impacts, I think this is pretty much straight line winds. I don't see a lot of directional shear. I see a lot of speed shear coming from the 850 millibar jet stream. But I don't see much support for tornadoes at this time in this setup. But we'll be keeping an eye on it, as always. And as far as the weekend, same thing. But again, your strongest lifting is going to be further north. So that leads to questionable whether or not we see the strongest storms. Oh, damn. Mets just made an amazing catch. That's McNeil for you. God, I love that guy. Let's see here. Does El Nino last through winter months and give us a better chance for snow? Let's see. Okay, so El Ninos do last through winter. Better chance for snow. That's a tricky one. Because the subtropical jet stream is stronger, and you tend to get more troughs over the eastern United States, it does increase the potential, but not guarantee. We've had plenty of El Ninos where we had almost very little snow, below normal snowfall. And then we've had some winters where it's just been crazy. As always, with all these factors, there is no hard definition. A lot of it depends on the interaction of various features. The interaction of high latitude blocking with the subtropical jet stream, which means you have plenty of moisture, you get cold air thrown in there, boom, plenty of winter storms for the mid-Atlantic and southern New England. Northern New England usually doesn't do as well because the storm track is further south. So that could be certainly a factor. But a lot of that depends on whether or not you get high latitude blocking. And the Yankees are leading for now. We'll see what happens. Okay, let's see what questions we have here on YouTube.
I had two, but Dylan redacted one of his for some reason.
I might have answered it already. Who knows?
Maybe, who knows?
Will thunderstorm activity for tomorrow be like Tuesday where there wasn't much lightning and wind, or feature more lightning? I think it kind of depends on where you were. The storms that we experienced had a ton of lightning. Yeah. It just kind of depends on the thunderstorm interaction. The precipitable water value will be higher towards the Delaware River Valley, so those thunderstorms will probably be more dynamic and more potential for frequent lightning. Not necessarily stronger, but more lightning involved in them because there's going to be more moisture and higher levels of water vapor. But that's pretty much as far as I'll go in that respect. Pipe here, north here. Oh, okay. Yeah, never mind. That's weird. People are weird.
It's one of them nights.
It is one of the... Oh... You know, that's how you know you're starting to get popularity, because you start to get some very, very rude individuals showing up. Just wait for the winter when we actually have winter storms. Anything on Twitter or X or X marks the spot? Nada. Same here in Union County. Lots of lightning, knocked out power after one strike. Yeah, it was pretty nasty out there. I will say this. Oh man, my camera went blurry for a minute there. Still is blurry. I think I scared it. There it is. Okay, good. I spooked it. There you go. And talking about that, next week is birthday week. I will still be doing the live chat Okay, I'll still be doing that. I'll probably wear a birthday hat. Should we get a little cake?
Oh boy.
I'm gonna get a little cake. I'm gonna sing happy birthday to me. What do you think?
Whatever you want, honey. Whatever you want.
Well, we'll see. I might not. I don't know. It kind of depends on what's happening. We might go out and get some steak. When is that anyway?
What day does it fall on?
Let's see here. Live chat's on the 2nd, and then my birthday is there after that. So might not be too bad. Maybe we'll do that. So we'll do the live chat next. My birthday will be on a Thursday. No, Thursday. The 3rd. Yeah. Because Monday's still July. I don't know.
But never mind.
I don't know. I don't know what.
I know you don't.
I have no idea what day it is anymore.
Anyone?
I don't know, man. Ever since 2020, I've lost track of days. I have no idea. Yes, what was I saying? Oh, yeah. Next week, definitely, we have the live chat. We'll see how that goes. That should be fun. But we pretty much answered all the questions tonight. I really wanted to get done with the whole AMOC. I think did I answer everyone's questions on this, because I think that it's a really important thing to go over and to really make sure people understand. I'm doing my part. We'll see what happens. You know what I mean?
You got something on YouTube.
Uh-oh. Bad? We'll see.
No, I questioned you.
Oh. Well, okay. Manny J. All right. Will the stronger storms closer to the low up north possibly create subsidence in our area? That is an excellent question. And the answer is possibly. Depending on the orientation and the intensity of the storms, it could set up where we get sinking air over our region, which is why I'm not as gung-ho with severe weather for us. I really like it more in central New York. Because, again, here, let me see if I could pull this up real fast. See what I can do here. I want to pull up the 500 millibar vorticity. Okay. Hang with me for 1 second because I really want to show this. Perfect. Here we go. New England. Where are you? All right, we'll go northeast. Fine. Okay, perfect. Okay, so there we go. Okay, so for tomorrow, as we set up with this shortwave, look where all the strongest lifting is. So by tomorrow afternoon, it's lifting through New England, which means your strongest thunderstorm should be up here. Now, that doesn't negate the fact that we're going to have thunderstorms and lifting down here, but clearly the strongest lifting is up here, which means we should see that shift in the strongest thunderstorms, and we could end up with sinking air over our neck of the woods, which limits the thunderstorm strength. Are the Canadian fires still burning, and can we expect smoke in an area anytime soon? At least I always go by this by 48 hours out, because wind direction, a slight shift either way can make a big difference. The fires are still going because people don't understand the concept of fire and water. Oh yeah, South Park Blame Canada really, really, really stands out to me right now. They really did call. Yeah, cartoons have been really good at calling the future lately. I don't know what that's about. But unfortunately, we still have that issue. But at least over the next 48 hours, we shouldn't have any issue with air quality. And hopefully that remains the case. I might be a little concerned for Sunday because we're going to have northwesterly winds at all levels of the atmosphere. So, yeah, it might be cooler, but might be dealing with some smoke as well. So we'll be watching that very carefully. So I think that's it for tonight. I think we got everything covered. I thank you again for your questions. It's really been outstanding. You guys asked some amazing questions, and I really appreciate it. It keeps me on my toes, that is for sure. So, guys, have a good night. Stay safe out there with that heat. I'm really serious. It's going to be bad. Drink plenty of water and stay indoors if you can. Have a wonderful night. And as always, stay safe out there.